Well, heidi ho, neighbor.
Hey, hey, what's up?
Is that just me or did the intro music change?
I think that the intro music did change. Normally, I'd be bobbing my
It
head
was much
to it.
more like lo-fi. It was
Yeah,
just smooth. Anyways, so hi, hey, hello. Thanks for joining us, everybody. Another week down, another Threat Thursday live coming at you. Today, we're kind of following along with the trend we've been showing you guys since the new year. We've had a lot of cloud stuff made here recently, so we wanted to show you one that's dealing with AWS. It's basically creating an IAM backdoor and allowing you to set persistence in some AWS resources. All in all, this one's pretty cool. Well, same as every other week, we'll go over it, talk about it, what it does real quick, let you see what happens, and then talk about some detections and fun stuff. Hopefully, we keep it under 20 minutes. We'll see if we do or not. We've been good about it lately.
yeah. We've been good about keeping it right underneath it.
So this one, all in all, is pretty interesting. It's takes a little bit of setup. It's taking advantage of a specific style scenario when it comes to engagements or testing these kind of behaviors. This threat basically assumes you've compromised an endpoint already in the environment. It's some kind of IT administrator, cloud administrator, or a dev, something like that. And they've in, not enumerated, authenticated with their resources already. They did the SSO login, whatever it is, however they go about it. So they have an active session in AWS from their endpoint that you've compromised. This for us is a little bit, I wouldn't say necessarily sneakier, but stealthier because we're not having to go and do any kind of crazy enumeration of shares or files, folders, things like that. The threat starts off with some enumeration, notices that the user is already authenticated, so there's no need to go find creds. We have creds. So now we're going to piggyback off that session, create our own user, add them to some policies, things like that, and boom, persistence. Kind of about wraps it up, right, Tyler?
Yeah, that just about sums up what all it's going to do. Like I said, it's pretty straightforward. And again, I just want to hit on before we go over it that it is predicated, like Trey had said, it's predicated on having an AWS user logged in and authenticated via the AWS CLI, very similar to how our threat we went over a few weeks ago with the AWS S3 enumeration and exfiltration. It's reliant on an adversary landing on a box that already has authenticated credentials to AWS, such as a dev or something like that, or an administrator. And then just kind of we're making a backdoor off a piggyback off of a machine that we've already breached. So a couple of layers in there, but with that being said, I think it's probably time to just go ahead and jump into it and show what we're talking about.
Yeah, let's show it off.
So up first, we'll do just like we did the other week, where we'll go in, we'll show the threat before it's executed, and then show the threat after it's executed, and then you can see what the results might look like. So in there, we just have a little info note for the user that's going to run it. That's not really pertinent um, to the thread itself. But up first, we have a variable that we need to set an AWS user. So here we'll just list the username for the user that we're trying to create with the backdoor. Then we'll jump into some of the enumeration, like Trey had said. So we'll list some users, see who's already on there, do some S3 enumeration, see what buckets this user has access to. We'll describe some instances, list some zones, look at some networking stuff. And then after those enumeration phases, we're going to get into the actual backdoor creation itself. So we'll create a user utilizing that variable we set above, which would be site backdoor one, I believe is the default for it.
Yep.
Then we will attach a user policy. The user policy, we want admin access, right? If you can give me admin access, I want admin access. So we'll go ahead and give them the administrative access to that backdoor account that we just created. And then we'll scroll down. We'll just go ahead and list them to make sure that it worked. You could have had if the user you're authenticated as doesn't have permissions to attach that policy to this new account, then obviously it won't work, right? So we want to list out what we want to list out what policies that new user we've created has. Then we're going to create an access key. We're going to list the access key. From that point, we'll be able to just simply copy and paste it out of there, throw it in any AWS config file on any machine, and then be able to authenticate as that user from whatever endpoint we're on. And then last step here, this is a part of the cleanup step where it's agreeing what the access key is, so it's able to delete the account afterwards.
So it'll go through, it'll delete the access keys, detach user policies, and then finally delete the user itself. So you
Yes.
guys don't have to worry about doing all of that. It's going to do it for you.
Yeah. So if you're just going to run the threat, to test your visibility or test, what you're able to see if this is even able to be done in your environment, it provides the cleanup steps in the end. So like Trey said, it'll delete it, and you don't have to worry about this lone backdoor account with admin access lying around. But as we jump into it, I think we only use the run module for this. So when we get to the detection piece, we should be able to see all of it pretty easily. But up first, we have, like we said, just enumerating those S3 buckets, seeing what that user has access to. We have the cryptid society. That should sound pretty familiar to anyone that's been on one of these before, one of these Threat Thursdays before. Then we'll go in, we'll describe any instances that we have. We don't have any in this case. Any zones, we don't have any, which is fine. And then we'll get into the creating of the user. So like you said, we're just going to create the user with that variable that we had set, that sites backdoor 1. Here you can see that it's created. It's got the user ID and the RN associated to it. Awesome. So step 1 done of having that account created, but it doesn't have any permissions yet. So we'll go ahead and attach this administrator access policy to that user. I believe that this is a default policy, so you don't even have to upload a policy or create one. It's one that's just inherently accessible via AWS. So we go ahead and we give it administrator access. We don't get any errors, but we do a double check just to make sure that it works, that we have these permissions that we think we have before we follow on with future steps, right? So we're able to see that, yes, we do have administrator access on this site backdoor 1 account. Fantastic. And then we'll move up, we'll create an access key. The reason you want to create an access key and not just the user account is so that way you're able to, like I said, copy out this access key ID and this secret access key ID, throw it in your AWS config file, and then you'll be able to authenticate as this user from essentially wherever you are, as long as there isn't, any kind of ACL or anything like that that's prohibiting you from accessing that AWS portal. You should be able to access this from essentially anywhere, right? And then next up, again, we're just listing out the access key. So that way we're able to see that everything was created, we're active, everything is good. There's a delay. This is a part of a lot of our emulations to just give you time to pause the emulation or do something like that before we run the cleanup steps. And then this is the only part of the cleanup steps that we included. I deleted all the other ones because I wanted the account to persist, in our environment. And then that's the threat pretty much as it goes through, just some simple enumeration, making sure that it has the correct credentials, creating that backdoor user, giving them administrator access, and then telling AWS, hey, give me the access key, give me the secret access key, so that way you can take that and log in as this user from wherever you want to be.
Yeah, now we've got persistence. Now we've got another way to potentially infill or exfil data. There's so many other uses we have from this point on. So
Well,
we
not
would
only persistence, but privilege escalation as well. I mean, depending on, we've created an admin account that nobody knows about. If the user we were on maybe just wasn't a full admin, just had like limited permissions, but was able to create users and give them a additional rights. I mean, you're looking at privilege escalation as well.
And now this is a threat that we wouldn't typically look at necessarily running in a vacuum for our engagements. This might be a particular phase where we're setting our persistence in cloud resources. We have some that kind of mimic this as well for Azure. And then from there, you can kind of tailor this to whatever else you want to do next. Are you planning on doing more data exfiltration? Are you planning on doing any kind of lateral movement or moving stuff between AWS resources? There's a lot of stuff you could easily bolt on to this threat and make it that much beefier and a more holistic kill chain. This is just a small piece.
Yeah, for sure. It's definitely just, a piece of what else you can add on to it. I think too, just having multiple different users doing things makes it more difficult. Makes it more difficult from a detection standpoint, because I see a lot of times people will see one user account or one computer name or something like that doing something, and they kind of hyper focus in just on that specific user or box or network VLAN, whatever it is, and they kind of forget that there's other users, there's other things that could happen. So if you're able to, you start this this campaign, this threat, this attack with, T Bilberry at AWS, whatever, and you're using those accounts, you create a backdoor account, maybe that doesn't get seen, you switch over to that. Now they're focusing just on T Bilberry and what that account is doing, and not focusing on this backdoor account.
Which we've seen happen in prior engagements where people
Yeah.
just get so lost in digging into one rabbit hole, they miss everything else happening over
Yeah.
here.
Yeah, happens all the time. I mean, just being overloaded, just being inundated with all of that information could be a lot to kind of parse through. And if you're trying to just do a quick, smash and grab all the way through it, you have one user that seems normal, like, like I said, like a T Bilberry account doing a bunch of stuff. You create this and you kind of more silently or stealthily do stuff on the side with it. They might not even see it before you get done doing what you're doing.
Yeah. So let's
Uh,
talk detections real quick. This is one where they're kind of interesting, and this is one I would personally again harp on state-based changes. If you're trying to do stuff like looking at specific command line usage or keywords, things like that, there's more than one way to create users and to assign policies and all of these different little steps that we ran. So any one particular detection on that won't be necessarily super robust. But if you're doing things like auditing your CloudTrail events, you're looking for changes to those groups or those policies, you're looking for state changes like new users created. That kind of stuff is going to have a much higher fidelity, I would think.
Yeah, for sure. But say what we have here that we'll go over, these are just logs that came from the endpoint. We aren't ingesting any of the CloudTrail logs into Splunk yet. So you definitely would get some additional detections utilizing your CloudTrail logs, like you said, to monitor for new user creation, new access keys being created, things like that. You definitely are going to want to monitor for. But as far as the endpoint logs are concerned, there's still plenty here that you could kind of hunt through and see if there's anomalous activity happening. So
Mhm.
the first one up is just having a suspicious parent image for the aws.exe. This is very similar. It's actually the identical thing. I just changed the image name. This is very similar to our PowerShell and CMD suspicious parent image query that we talk about probably on every Threat Thursday. So we're just looking for if AWS, if the image or process of AWS is started by a parent process or parent image that is not in System32 program files or program files x86. Again, that's where your legitimate, mostly trusted, less risk um, executables and things should be coming from, right? If it's in program files, it's probably an already installed piece of software that is more likely to be legitimate than if it's outside of this. If this is running in temp or this is running in administrator campaigns, um, like this is running outside of this user profile campaigns, like that's probably something that should be investigated. But anyway, all of the command line listings that we have over here, we could see that because everything was ran with the run module, it's all just clearly logged for process creation. We can see them attaching the policy. We could see the access key being created, the user being created, so on and so forth. But this big chunk, we kind of broke it down even more in these futures, in these additional detections. So the first one we have of those is AWS enumeration. So we're just doing some keyword searching, which is not necessarily the best way to do threat hunting, but if it works, right? So we do some keyword searching for S3 LS, which will list out the S3 buckets, EC2 describe with the dash. So anything that they're trying to describe inside of the EC2 parameters, and then any list dash anything. So you could list dash users, you could do groups, you could do attach user policies. It's kind of just an all-encompassing keyword search there. And there we see some enumeration with the describing of the instances, listing out the access keys, querying the access keys again in a little bit of a different way, user policies and users, etc. So here we prove that there's some AWS enumeration. And then next up, we're looking for the actual actions on objectives or the impact statements, which is the AWS user and access key creation. So that again is just a keyword search, looking for IAM and then create dash whatever. So We see again that this TTIAM backdoor.exe has spawned AWS.exe, and AWS has then created this site backdoor one, or the site backdoor one user, and then created a site backdoor one access key that goes along with that user. And then lastly on there, just the network connections from the implant. So this isn't something you could really have pre-staged per se, but we know based off of these previous detections of the CTIAM backdoor, TTIAM backdoor, IAM backdoor, that that's probably something we want to take a look at. So we set the image to TTIAM backdoor, and then we just query the values of the query names or any DNS requests that that image pushes out, and the values of the destination IP. So that way it'll grab any IP addresses that it sets a network connection up to. You probably, if you employ this last one in your environment, probably just have a bunch for the destination IP addresses. You could probably have those set to just public IPs, exclude any private IP addresses or things you would think are known good, and maybe do it that way. But this is really a detection for after you kind of already have a thought in your head that something else needs to be investigated, right?
And most of these would require you understanding your users and their typical behavior, right? Because I mean, if I was to look at this just out of the norm, not already knowing we did something, this looks like normal IT administrator stuff, like a new user is being onboarded, something like that.
Well,
So this,
I say that is a great point because you can also see if this will work live. So not just for the user being created, but you could change the field or add the field of user into it. So maybe you have a list of like known AWS administrators or something like that, and you want to monitor that list and see if anybody outside of that is doing something, or even you could change it to computer name or host or anything like that. Because you couldn't change it to host. That's what you get for doing it live. Computer name. You could change it to computer name and then see if anything like that. So definitely having, like you said, having a baseline and knowing what is normal on your network, and knowing what users are valid and kind of what is expected activity is really invaluable. And just kind of making your allow listing or kind of helping your risk threshold into what is abnormal is really great just by using some fields like user, computer name, things like that.
awesome. So yeah, that is our AWS IAM backdoor threat that we had for you guys. We're going to have some more of these that we can show off throughout the year, and we're kind of deep diving on doing some revamp from threats we created previously for threat actors. There's a lot of stuff happening right now, so it's kind of given us some good opportunities to go back and revisit some old threats and give you guys some fresh new content added in. And I would say with that, the last thing I'll say before we disappear is Unicon. It is coming up. What day was that, Tyler?
That should be April 9th. I believe it's next Wednesday.
Is that next Wednesday? Or is it 2 Wednesdays from now? It's close.
2 Wednesdays from now, but it is April 9th.
So lots of good speakers, lots of awesome things happening. Whole day virtual event. Feel free to hop in and check it out if you wish. To find more info on Unicon, go check out the scythe.io website. You'll find it there. And with that, any parting words, Tyler?
I don't think I have anything. Thanks everyone for hopping on, and hope to see you again in the future.
Yep. Till next time, everybody.
Everybody.